Hello and welcome. This is Eric Miskell with EMSNOW on the show floor at IPC Apex 2024. We're actually in the IPC booth, but meeting with iNEMI. We have Frank Mullany, who is the Director of Road Mapping with iNEMI. Frank, welcome. Thanks for taking some time here. Why don't you begin by giving everybody a quick overview of who iNEMI is and what their role is in the industry.
Thanks for the opportunity. Yes, iNEMI, it's a not-for-profit consortium of companies that come together to look at technology problems, basically identify what are the key technology challenges that need to be addressed inside electronics manufacturing. And then we set up various projects on a collaborative basis, pre-competitive type stuff, to try and address those challenges collaboratively. So basically, you're looking at issues that need across the supply chain, across the ecosystem type of approach to actually solve them.
So all of the type of companies who are exhibiting here would be potential
Absolutely.
members?
Potential members, yes.
Okay,
Yeah.
Director of Road Mapping.
So, Director of Road Mapping. Well, I get to do the fun bit of identifying what the problems are and where the pain points for the industry are. So, I work with a very large set of contributors right across the industry who work on a voluntary basis, both from members and non-members. And together in small teams and online calls, we try and figure out what are the needs for the future, what are the challenges, and what are the potential solutions. And then we put that up on an online roadmap. It's roadmap.inemi.org. You can actually see it there. Some of our latest content is already up online today.
Okay. So tell me, what are as you're seeing it currently, what are the big trends?
So the big trends, well, it's a simple story that we've all heard for years, right? We're looking for electronics to be smaller, faster, to run hotter and greener, and to be more cheaply produced. So no big surprises there. But what we're coming to is a new transition. We have already had the big transition from a single die in a single package to multiple dies into multiple package, right? The heterogeneous integration story. Now we're coming to a second major transition where we're looking at a blurring of the lines between PCB and substrate, between the PCB and packaging. So we have things like direct attach of dies. We have large-scale substrates which look a bit like PCBs. So the way the industry is actually addressing that kind of solution is changing by the day. Some players are moving upstream, other players are moving downstream, but all are trying to provide that connectivity, interconnect capability to combine a huge range of functions, right? From electronics, photonics, micromechanical, sensors, all into a single compact solution. What we're terming complex integrated systems, actually. We have a recent white paper with IPC on the subject.
Okay. So with trends come challenges, obviously. What are the related challenges that you have with all this?
Yeah, so you look at design. Let's start at the beginning. Design, right? So you have a huge range of connectivity options now because of that blurring that I was talking about. So where you put functions and how you connect them together is no longer obvious, and therefore your system design has to start from the system and get down deeper before you can make a decision on these things. Then with the huge range of functions in there, you really need a multi-domain approach to simulation and design as well. You can't leave the thermals until the end, because it's going to be tied up with the way you do your interconnect, the way you do your packaging. So huge nightmares there to be addressed. And then you have other areas such as test, sustainability, where because everything is integrated together, what's a known good subsystem or a component now? What is that inside a highly integrated solution? But the final one I'll highlight is to actually address all of these, you need people who are well trained across a range of disciplines. So a multidisciplinary approach is going to really come to the fore. We will still need our specialists, but we're going to need a lot more folks who are comfortable hopping from domain to domain, from optical to electronics to thermal to physical, and who can converse well with the deep experts across the board. That may actually require changes right down at the undergraduate level of training to address.
Oh, interesting.
Yeah.
I must say, you talking about starting with design. I used to run a quick turn prototype assembly shop. And so we do design, get the material, build the boards. And inevitably there are problems because it's prototypes, right? But then the client would come in and we didn't start with design. We had to start with prove your manufacturing process, make sure you're doing it right. Then we'd investigate if the material's okay. Only then would the engineers even consider the fact that maybe there's an issue with the design, right? So, which is always interesting to me because I hear you, let's start with design. And I used to always say back then, maybe we should start with the design because we keep learning that that's usually where an issue is, right? There's so much critical decisions made at that point relative to materials and to process that flows down from there.
Yeah, and if you don't look at those up front, look at the full life cycle in your design work. You have to look well beyond just functionality, right? The boss comes in, he gives us a list of specs that he needs to meet. These are the functions that need to be done. That's not enough. And it's just because we can't partition things up nice and neatly with clear design rules between them. We have to consider the process. We have to consider testing. We have to consider the end of life. Even as we look at the basic functions that are required to sell the devices at the end of the day.
Right. So do you see any exciting areas coming out?
Well, I'm in technology road mapping, so we get to peek into the future in various areas, which is good fun. And you can easily identify some really great areas. What's happening in wireless communications above 100 gigahertz, right? There's huge changes right throughout the technology stack needed for that one. Look at quantum computing. It's just beginning to scale up there. Huge engineering challenges. You look at the integration of photonics and electronics. Mm-hmm. But the one that really hit me in the last 12 months as something that caught me from left field is what's happening in the area of sustainability. And that, I can see major changes coming down the tracks, both in terms of the outside pushes from society and the key stakeholders, consumers, governments, etc., and industry, but also from the technology side. How do you implement something like a circular economy for electronics? We're so used to electronics coming to end of life and then being disposed of. Mm-hmm. Well, no, the options now are beginning to explode. Do we repair? Do we remanufacture? Do we reuse in a different context? And how do we recycle?
Right.
So all of those have huge implications in terms of how we do it and how we approach the problem. They have technology implications. They have mindset implications. An absolutely fascinating area. I'll give you a very simple example to end on this one. I was at one paper where a guy was talking about recycling critical materials out of hard drives. And he was asked, okay, if I'm a designer, what's the one thing you would like me to take care of to make your life easier as a recycler? And he said, please don't put stickers on top of screws. My AI-driven robot for unscrewing and dismantling the wide range of hard drives has a hard time dealing with stickers on top of the screws because it can't optically identify where the screws are anymore. So we have to rethink everything from the ground all the way up again to try and implement that concept of a circular economy.
I must say I was kind of surprised as we were talking about the areas. AI was not mentioned.
That's a burning issue, both literally and metaphorically. And you have it both at the data center level, but also in the mobile device level, right? Because we talk about how AI and how much energy it's going to consume right back in the data center side of things. But it makes an awful lot more sense to try and push AI right out to the edge, because then you don't have to communicate very large amounts of data up and down through the system. So, putting AI onto drones, putting AI into, cars. It's a very simple example where you don't want to have to push it back to a central server.
Exactly.
And that's where I think we're going to see, from an electronic standpoint, we're going to see even more challenges on that side as well as on the data center side, in terms of how do you produce power efficient, compact AI that just doesn't burn out your batteries every time you switch on your end devices.
Listen, one last question as I hear you talking about the design piece. I remember years ago the term, and I don't hear it so much anymore, was the design for recycling or design for reuse. Is that still
there? Oh yeah, and there's an awful lot more work to be done there. Okay. And I just take, if I come back to that idea of complex integrated systems, the problem's going to get even tougher because you're now putting in multiple functions into an even smaller package. How do you extract out the materials that have either toxicological issues or there's value to be extracted in getting out those content? How do you do that when your system is so small and integrated?
Right.
So we're actually, by miniaturizing, we're making things tougher when it comes to the end of life. When we could, prior to this, we might be easily able to separate out components. Right. So lots of challenges there for the industry.
So tell me, just in closing, for people who are watching and listening who might have not been involved with iNEMI before and might want to get involved, what would you recommend?
Well, there's two routes. If you would like to dip your toe in and engage with us on the road mapping side, that's open to all. Right, so you can get to the link via the website roadmap.inemi.org. Alternatively, if you want to engage on the project side, where we're trying to come up with solutions in a collaborative manner across industry, then please feel free to reach out to the organization. We can have a chat at any point in time on that. Certainly, once you're a member, it is very easy to get projects up and running. Our bureaucracy, etc., because everybody funds their own activities, the bureaucracy involved in actually getting a collaborative project up and going is extremely light. It's remarkably light. So it's a great way of getting multiple players right along the supply chain to come together and address problems together in a collaborative manner.
Very good. I enjoyed this very much. This was very interesting.
Thanks for the opportunity.
Frank, thank you. Enjoyed it. Thank you.